Okay, now we are going to look at 2.7 and 2.8. Basically these, there's a lot of stuff here that most of you know. Okay, so 2.7, 2.8. What we're going to go through is basically some principles that,
Oh, wasn't me. That pushed me over.
okay, let's just stay down on the floor and then nobody can push you over, or no,
Yeah,
you
Max,
won't
you
fall,
shouldn't
or you won't fall.
Yeah, Max.
Are you accusing me?
No, I'm saying that either way, it's impossible if you are flat on your seat.
Yeah, Max, imagine there was a stool, there was no table there, and it was a hardwood floor.
Ouchers.
Yeah.
Believe me, you know, this
Pretend you're on the side
weekend,
of the cliff.
just a minute, this weekend, I thought I was very smart, right? I was painting in the house. I decided there was one spot I needed to touch up. So I didn't get the ladder out because it was downstairs.
Oh
That's
my
too
God.
hard. Yeah. I get it.
So I stepped on the toilet seat and then stepped up onto the counter in the bathroom
That's not bad.
to paint something. When I went to come back down, I missed the toilet. No, it did not break. I just missed it. And I fell backwards into the shower tub.
Oh,
And right now I have a really bad bruised area right here. And I have a really stiff neck up here. And I have a spot down here that is all bruised because I hit it hard. And the sad thing was my husband couldn't hear me yelling. He was outside.
So you're in the bathroom.
So I was yelling, and so finally I decided, okay, he's not coming. I just have to get back up. And then he comes in and he goes up and upstairs and he goes, our shower curtain is down. Do you know anything about that? Not a thing. No, I told him what happened.
That same,
So that shower curtain had lots of paint on it because I was carrying the paint too.
So did it spill? Was it like
It spilled.
did it spill?
There wasn't a ton, but it spilled. It got all over the shower curtain, and I said, I think we're getting a new shower curtain. I will wipe up the stuff on the tub, but I'm not cleaning that shower curtain. Plus, it needed a new liner anyway,
So what if you did that on purpose?
I didn't. Believe me, why would I do something on purpose to hurt myself?
Oh,
That's kind of I'm sorry, it's not fun for
but
me.
what if your husband really liked that shower curtain? And
Oh, he did, believe me, he told me. But you have to remember, I'm moving into his house because we just got married. So everything in his house is what he picked out. So he has to make some adjustments for me.
You need to womanify it.
I need to put it in because I have my own opinion. So most of it I agree on what he's done, but there's every once in a while I say, I like something different. So we,
Like what? Give us one example.
the shower curtain.
Well, I mean,
Another one.
Wait. So you didn't like the shower curtain? So it was like a,
I think it makes it too dark in there. I'd rather have a lighter shower curtain that makes it lighter.
it's kind of a win-loss kind of thing.
Yeah,
Okay.
yeah. Okay, so 2.7 and 2.8. We are going to go through these. We are going to talk about addition properties. And multiplication properties. What I care on this is not that you know the name of the property, but you know what it tells you or what you get every time. Okay, these are simple things. I am not interested in the triangles that they make, the addition and subtraction triangles, or the addition or the multiplication and division triangles.
Are we doing 2.7 and 2.8 at the
Yes,
same
this
time?
is 2.7, this is 2.8, okay? So addition properties and multiplication properties, they're pretty straightforward, okay? So first thing is if I have a number A, its opposite is the opposite of A. That's what's written. It's negative A. okay, or the opposite of A. So given a number, the opposite is always written as negative A, okay? If I add A and its opposite, okay, so this is a number plus its opposite, I get 0. Example, so up here, 3 is my number, the opposite is negative 3. If I take 3 plus negative 3, I will get 0 because I go 3 to the right, 3 to the left, because remember this is a directional sign on my number line. Basically what that's saying is 1, 2, 3,
It's
so
just
that goes
3 minus
3.
3.
Yeah, it is, but I'm just showing you. Then it goes back to the left 3 and I end up at 0, okay? So this sign is going to the right, this sign is going to the left, we end up back at 0, and so that's where that comes about. That's very important that we know we can add the additive added the opposite to get 0, because when we start solving equations, if we want to eliminate a number on one side, we just add its inverse. Or its opposite, sorry, not the inverse, the opposite, okay? So that's important because it eliminates it on the side that it's on. We'll talk about equality, which is the next step, okay? If I have a number and I add C to it, let's say, well, first of all, if I have A is equal to B, so I'm stating that. If A is equal to B, if they're equal, then A plus C is equal to B plus C. What is that saying? Saying that if I have two things that are equal, if I add the same number to both sides, they will still be equal. Okay, let's look at an example. If I say that A plus, let's not use A there, X plus, let's just do it this way. Okay, we're going to do the absolute value of negative 3 is equal to 3. Does everybody agree with that? The absolute value, which is the distance from 0,
Yep.
equals 3. So
Yep.
that is a true statement. A is equal to B. So then, if I take the absolute value of negative 3 and add 5 to it, so I'm adding 5, and I take the B, which is 3, and add 5 to it, they are still equal. That makes sense? So it's basically saying, if I start out with two things that are equal, if I add something to both of them, the exact same thing to both of them, they are still equal. Does everybody agree with that? Because the absolute value of 3 is still 3. Plus 5, that's 8 on that side. The other side is 3 plus 5, which is 8. So they're the same. Okay? So it doesn't matter. As long as you start with something that's equal, you can add the same thing to both sides, and it remains equal. Okay, that's all that's saying. Okay. If we have A, that is the same as 1 times A. Okay? Not times, I'm sorry, plus 0. I got to do this backwards. Sorry. 0 plus A. This is called the additive identity. The additive identity. You know why? If I add 0, I still get back the same identical thing. Now, why is this important? Because basically we can say if we're adding 0 to any number, it's just going to be equal to the number itself. Now, we should know that. If I add 3 plus 0, it still equals 3. It equals 0? Really? Yeah, it equals 3. Okay. If I add 25 and 0, it's still equal to
0.
25. Thank you. Okay, so That's very, it's common sense. I don't care if you know that's called the additive identity. I just want you to know if I add 0 to something, it does not change it. It stays the same. Sometimes we add special cases of 0 to things to make things simpler. Okay? And so that's the part that in the future we might say, oh, now we're going to add a special form of 0. It equals 0, but we're going to add that there to simplify problems. And sometimes that's where it gets a little bit, oh, we have to think back. That's just 0, so we can add it and it doesn't change the problem. Okay? So it's kind of like we use this other one a lot. We'll talk about it. So those are basically all the principles. I want you to know that when you have A, its opposite is negative A. Okay? I want you to know if you add a number and its opposite, they always make 0. I want you to know if I have two things that are equal, I can add something to both sides, identical numbers to both sides, and they will still remain equal. Okay? I also want you to know that if I add 0 to a number or anything, an x or whatever, then it's still whatever that number was or that variable was. Okay? So those are the things I want you to be able to identify. You should know that one, you should know this one, you should know this one, which is all captured there, and then we should know number 4. Okay? So those are the 4 things about addition that I want you to know. I don't care if you know what the name of them is. It really doesn't bother me if you don't know it, because I'll tell you, I never go through life and say, well, oh, you just used the additive identity property. Sorry, I don't actually say that. Or the additive, the opposite property. It's not called that, but anyway, we don't go through saying that. So I want you to know the basis of what these stand for, what they mean. That is always true, because we'll start using those kind of things. Okay? Now, the next one is all about multiplication. Now remember, addition properties also include subtraction, because remember, we define subtraction as adding the opposite. So really, addition and subtraction are the same thing. We just change it to the opposite number and we add it. And that's the whole definition of subtraction. So all those properties that fit there actually fit with subtraction also, because subtraction is defined as adding the opposite. Okay? So multiplication also applies to division, because multiplication and division are the same. Division is multiplying by the reciprocal. Okay, which we learned all the way back in grade school when we had to flip the number. That was getting the reciprocal. We multiplied by it. That was what we did to get our answer to a division problem. Okay, especially when we were doing fractions. Okay, that's because division is really multiplying by the reciprocal. That's how we define it. It's a multiplication problem. We just have to take its reciprocal. So the reciprocal, if we have A, then its reciprocal is 1 over A. Okay. Or if we have CD, the reciprocal, that's not a D, there we go, CD, then the reciprocal is DC, because we just flipped them. Okay, so that's how they become a multiplication problem. Change them to the reciprocal. Just like up here, we change the number to its opposite, and we add that if it's subtraction. So we can change them into that using the definition here that A and the opposite of A is negative A. Okay? But subtraction is just adding that opposite instead of this. Okay? If we get down here, multiply is the same as division. All I have to do is change the A to being its reciprocal, and then I multiply by those reciprocals. So here we add the opposite, here we change them and make their reciprocal. So this becomes an addition problem, this becomes a multiplying problem. So really we only have addition and multiplication, because we can change the other problems into adding and multiplying. Okay? Yes?
Isn't the reciprocal of A is A over 1?
No, it is not. That's actually how it's written. Because if I have any whole number, let's just think of 23, okay, to make it into a fraction, I would divide it by 1, okay? Because 23 divided by 1, you're pulling us into the next thing we're going to say, okay? 23 divided by 1 is the same as 23, okay? It's an implied one. We don't write it. Mathematicians are lazy. Okay, we don't write it, but to make it then into a reciprocal, we flip that, which gives us 1 over 23. Does that make sense? So this would be 1 over 23. Okay, this principle right here brings us to our next thing. If I multiply anything by 1 or divide it by 1, it's still going to equal the same thing. Okay, so basically, if I have 1 times A, that will always equal A. Or if I have A divided by 1, that will always equal A. So no matter whether I multiply by 1 or divide by 1, I'm still going to get the same number. Okay? But again, that's a principle that we should know. And that's where this is important, because when we start dealing with those, you need to realize that's just really A divided by 1, and it's going to be the whole number itself. Okay? So if I divide a number by 1 or multiply it by a number by 1, it gives you back the original number. That's called the identity. Okay? Now, we have this where you add a number and its opposite and it becomes 0. Well, this is multiplication. And then we have reciprocals. So our last one is this. If you take a number and multiply by its reciprocal, what do you get? I take A and I multiply it by its reciprocal, what do I get? I get 1. I don't get 0 this time. I get 1 this time. Because the identity is 1. Since the identity is 1, then when I multiply these two, it's going to give me that 1. It's kind of like this. The identity is 0. So when I add them, they add up to 0. Okay? So if you look at this, A is opposite is negative A. You add the number and its opposite, you get 0. 0 is our additive identity, that when I add it to the number, it's no longer, it's just the same. If you add the same number to all three, it works. Okay? So here, A and 1 over A are reciprocals. Okay? A times 1 over A, so I put the two together, that's equal 1. Okay? Well, the identity is 1 times A is equal to A, or A divided by 1 is A. Okay? The last one says this. If I have two numbers that are equal, then A times C equals B times C. So if they are equal to start out with, it should be common sense, if they're equal to start out with, if I multiply both of them by the same number, they're still going to be equal. Okay? Example, if I have the square root, or let's just take a different one. If I have 2/3 is equal 2 4 6. Is that a true statement? 2/3 is equal to 4/6. Does everybody agree with that? Okay. So if I multiply 2/3 by 3, and I multiply 4/6 by 3, you should get the same answer. Okay? It's equal, but let's check. Reduce that, that becomes 2. Agree? Cancel that and that becomes 3. Or 2. 3 and 3, that equals 1. So this is 2. Okay? I'm just doing plain multiplication of fractions there. Okay? Let's look here. We could do it this way. 4 times 3 is what? 12. 12 divided by 6 is 2. We could have done the same thing here. 2 times 3 is 6. 6 divided by 3 is 2. Notice that they are still equal. Even though I multiplied them by something, as long as I multiplied them by the same thing, they're still equal. We will use that concept over and over and over and over and over and over again when we start solving equations, which is what we're going into next section. In chapter 3, we're going to start solving equations. Okay? These concepts are very important to solving them. That's why we can do it, because of these reasons. People always like, let's memorize this. No, let's just think about it. We want to make it 0, because when we add 0 to this, we just get it back. Okay? And so we'll start talking about how these come into play, and it's better than memorizing one of my steps. Okay? So that's the point that I'm trying to make with these. Okay? Questions on any of this? So, we are going to take a break.